We streaming? Yeah. Okay. I think we're live. Pretty good, pretty good. Right, okay. I think yesterday I set up, I get lost at this point. Yeah, no, compiler, not the virtual machine. Yeah, I set up the compiler. Something's totally off. So I guess today is the first thing on the checklist. Luckily, I left myself a list for today. And right here. Okay, there were a couple of things. That test passes. And it shouldn't. Because yeah, there's the compile method's empty. Actually, I just realized I should check. Did I have a token literal method on program? Okay. I guess this could be better. This can be a 4. Self dot statements. And what did I construct? Our program little gonna be a slice of you wait. It's undefined at this point. Control is thing empty dot alloc print allocator. Statement dot token literal. Allocator. I do need to pass the... Okay, yeah, I can just do that. Program literal. Right. Then just return literal. Okay, what that means is in my test, print program dot token literal of allocator. Okay, maybe set now. Okay, yeah, that can be an error. Yep. Integer overflow. That's weird. Where, I mean, the only thing I can think of is cater FMT. Is it because maybe program literal is undefined? What's the error? Integer overflow. So I call alloc print here. UA comma size. Maybe undefined doesn't have size. No. How did I do the other ones? Okay, slice of U8 is that. Okay, so the parser's doing its job. Because the statement is correct. It's 1 and yeah. So that's good news. So it's my test. My test is wrong. Okay. How is this test passing? Okay, mystery. Standard.debug.print. It's a string. Is it a string? No, it's not. What does make return? Okay, slicer U8. Make it an instruction. Sec dash source slash code. $64 31 205. That's just like completely wrong. It's not even like close. What am I looking for? Yeah, sig guide. This. Excuse me, jeez. Yep, that's not close. Also, there should be like 3 lines. Expected bytes. I mean, I could just add opcode dot op constant. Because that's the instruction I'm expecting. Then I can just remove. And expected bytes now should match the instructions. Okay, and I think I've got to get int from enum. I got to do the same here. Enum. Oops, that's wrong. Should be here. Okay. Think I don't. Yeah, I don't need that. And instead of I+1, just do I. That's crazy. How is it passing? Am I checking the right things? Oh, no, no, no. Standard.debug.print day p comma instruction of I. Why does it fail when I print the output? Expected 0 found that. That is so weird. Why? Actually, expected bytes is not correct. I'm right, that's read as null terminated. I think. I don't think that's right. Let me check the doc. I'm doing something terribly wrong. I have a feeling it might be the way I am declaring my slice. Why does it sound so weird? I need some water. Excuse me. Slices. Slices. A pointer and a length. Right. The slices length is known at runtime. mean, this is what I'm trying to do, really. Jeez, what's wrong with my eye? Okay, so that's what I'm trying to do. Alternative initialization using result slice. Hang on. I guess I don't need. I don't need the enum because I'm not converting it when I test. Yeah. Fuck, actually I do. I do get the int from enum. So I'll leave that in there. That's not it. Just hang on. It prints 0. Why is it found 144? That is weird. The fuck? These are printing and checking the same values. I'm doing something very wrong. But what? Okay, let me ask Cloud. What are the ways in which I can declare a slice zig? Because it talks about all the ones except the one I use. Found it quite useless with zig, to be fair. cloud. Using result location. Expect equal slices. 32. Fuck. Am I doing... No, I'm right. Why didn't I just do that? Testing dot expect equal slices. U8. Right. What's the expected? Test dot expected bytes, comma, instruction. No way, come on. Oh, I know. Why don't I change? So the test is working. So it expects 0. What did I change? No, it's not working. That's weird. Change this back. What happens? And do right. The expected value first. Expected actual. Yeah. Right. Expected 00 FF but found 0300. What is my input? Why is this 3? Expect equals slices, slice, which is, yeah, made from the array. And then alt slice, it's just a result location. What I don't understand is why that doesn't make sense at all. It should be 0, 1, and this should be 0. Const instruction is make. Let me check my code. Okay. I don't know if this array is still available. I think I know why. It's so unreliable. I think, yeah. I don't think this is correct. Because for each instruction, it'll just overwrite the array. Is my guess. Okay, so what I'm gonna do is instruction equal to standard dot array list of u8 dot init. I guess I could also use, what's the name? Fix buffer. I mean, I'll use a fixed buffer instead. I'll optimize it later. Can this add a? No. Okay, and then I'm gonna get rid of this. This and that. So this is going to be instructions dot end. Second is check here array list. Okay, instruction dot. All right, I can just append. What did I have to append again? Okay, I see. For now, I'll just press the program every time it errors. Okay, and I byte and then height byte low byte. I don't need any of these. Don't need that. 10 instruction dot items. Slice of U8. Okay, see if that works. Oh yeah. Where's make? 13 testing dot allocator. Expected type, add a list, U8 null, but found const. Yeah, okay. Every time. Okay. Oh yeah, fuck. Testing dot allocator. Where's the memory section? Cool. Where's the test one? I'm guessing I gotta clean up myself. Const allocator is testing allocator. Oh, is it the right? Yeah, it is. Allocator dot dnet. Is it free or yeah? No, it's not. Okay, let me just check standard. Testing. Is it? I guess it's destroy. Destroy. It's not destroy because I think it's free. I mean, it's one of those. Yeah, free also requires an argument. So just dnet. What am I missing? That's the strange thing about when you're trying to learn a language. Even the smallest things take like fucking ages. There must be an example here. Ktor. Yeah, I think I know what I'm doing wrong. It's because my make method has to handle clearing memory. But I am using an arena allocator. I only want to allocate once. So let me check arena. Yeah. Hang on. Why am I making this so hard? I've already done this. One, two. There. Just get rid of these two. Come on. Oh my god, I know what the fuck I was doing wrong. Oh, can't believe. Oh no, that wasn't it. Thought that was it, but that wasn't it. Okay, finally. Now that looks correct. Only took about 30 minutes to figure that out. Now let's test what's wrong with the compiler. Source/compiler.zig. Okay. Yes, this was wrong. That's fixed now. Where's make? Yeah. Just move this here. Okay. How about now? Still passing, but I don't believe it. Well, of course I don't, because how the fuck is it passing? Expected. Yeah. Am I running the right tests? Yeah. Whoa. I'm gonna say, why did it say all 14 tests passed? There's only one test here. Yeah. When I run code, it says 1 source/compiler. That's weird. What the fuck? That is fucking weird. Fucking 14 tests. Is there another file called compiler? No, that's just one. Seg test. Is it source slash star? Slash, I don't know, something like that. Seg test. I should run all the tests. Expected a positional argument. Seg test star source. How did you do that? Okay, because there's no one entry point. The REPL? No? No. Okay. What the fuck? What's wrong with my... Yes. Okay, let me... Excuse me. Hello, cadet. Is that a pineapple on pizza? Yeah, it is. I guess you really like pineapple on pizza. I'm just struggling with my tests. Don't know what the fuck it's running. Pathhole. Fuck. I wonder if it's the same. Okay. Got instructions. And I do initialize the instructions. Yeah, but I don't read anything from them. Okay, let me print. The debug print. What's happening here? Yeah, it's empty, like it should be. Okay, this is... expected instructions. What does this look like? uncatted instruction dot items. Why is that empty? Instructions. That is wild. I don't know what's going on. What if I printed them in hex? Okay. Well, that's something. Which is fine. I think it can't be printed as string. Okay, at least. So that means I printed as. Okay, it's not empty. Thank God for that. So it must be here. Test instructions. What do I send? Expected and got. The fuck is got dot instructions? Say slice of U8, which is at this point empty. Okay, first of all, I think I can make this. Actually, I don't even need this. Because what I can do is testing dot expect equal slices. Okay, yeah, and then I think it needs a type. It's going to be U8. Okay. Like fucking good. At least I've got it to fail. But the constants are not right either. Int is object.integer is constant.integer. Right. And then I test it against expected equal constants of I. And enter value. Move this to the bottom. Okay, so somehow this still passes. Set and what was I checking? Expected constants, which is a slice of int. Does it need to be a const? Right. It does. Just equal int the value. Right. Maybe debug. And the debug dataset. Okay, so maybe they're either both wrong. They have to be. Standard debug print. Dot. Oh, hang on. I know why, because this got.constants is empty. Fuck's sakes. That's a rookie mistake. Set. Okay, that makes sense. I can leave it as it was. Whoa. Yeah. Actually, don't even need that. Right, and then change it to standard debug. Okay, and then before I check that, I assert got t dot expected constants outline matches dot constants dot len. Damn, it's a day of rookie mistakes. Okay. Finally. Well, there were a few mistakes on my end. And finally got the tests to fail on the compiler. Okay, now that that's done, I can get rid of these. Test compiled instructions. Okay. I suppose finally we can move on. I think I should no, I do print these. If I put this over here, yeah. Okay. Okay. Is it correct? 0, 1, 0, 2. Did I not give the same input? Whoa. Yeah. That's wrong. Should be 0 and 1. Silly. 2 items. Okay. Okay. Alright, so I guess now I could actually compile the input. Not sure how. So we've got. So what we need to be able to do, as far as I understand, is right now our input is a parsed program statements, and every time we encounter an integer, we need to push it to the stack. Oh no, we're not even that far yet, because we need to prepare the instructions for the virtual machine. So for 1 plus 2, what should happen is there should be instructions to push 2 numbers onto the stack, and then 1 to call add. I don't know if you need to pass the address for add, as in, let's say this one would push the numbers 1 and 2 onto the stack, and when I call add, do I need to, is it add memory address 1, memory address 2, or is it just implied? I guess it should be implied. Yeah, just add the last 2 entries on the stack. I guess. We'll find out. Oh, my back. Okay. Mm-hmm. I don't know why this was necessary. Testing seems a lot better on Zig. A lot more concise, I would say, compared to Go. Because, I mean, just for comparison, unless I've missed something in my tests. I don't think so. Well, I should just check. Yeah. Yep. Hang on. Just do arithmetic instructions. I did it because I don't want to use any. I'll just use separate tests. Right, yeah. So it's testing the same amount of things. But the number of lines to do the same is insane. But I guess it's thanks to the helpers in Zig. So this whole thing, 1, 2, 3, 4, 5, 6. Jeez. All those 6 things combined is what I've got in here. That's crazy. Okay. I mean, but don't take it as testing in Zig is better than Go. I think it's just concise. I still do like Go. I'm probably gonna skip this. I don't want to. I don't care. They are strings. They don't need to be pretty. Yeah, I'll move on for now. It's a lot more useful than undefined string compiler error that stops us from running the test because we need to write another test and run it. What do you mean? I don't know. I'm just gonna skip this too. It's just for like pretty printing the inputs. I'll get to it when there's a problem. I'm okay with reading hex for now anyways. As you can see, read operands supposed to be, hang on, unless it's not that. This other test is for a function that will be at the heart of instructions.string. Opcode, operands, bythread, op constant, that and then 2. Maybe, yeah, okay. As in the width of this number. Instruction is make. Oh, okay, I see what you mean. What you're trying to do. I think it's a test for the lookup. Not sure why it's needed. Read operands. Whatever that is, def and instruction. Yep. Minus the opcode. Yeah. Ah, fuck. Okay, now I see. I totally misunderstood this. So this is going in the opposite direction. Why is it just do use as a helper in the test? Or is there another? I don't know why we need this either. It's just like one line. Find it easier to define it where it's used. That's just me. The definition of an opcode to find out how wide the operands are and allocate a slice. Okay. I guess so this way you can run make and then read operands. It's like the counterpart, so you can assert that the end result is what you started with. Oh, okay. I'm gonna expose the function so that it can. All right. Okay. Allowing us to skip the definition lookup required by read operands. No, I'll think about this one. Not too sure. It's entirely necessary. Now that we have read operands, we can get rid of the blank string and properly print instructions. Has a string method and then you can format instruction. Okay, you just replace the name with the definition. Sorry, the op constant with the definition. Yeah, I think this is just like a visual helper for tests. Yeah. Yeah. Okay, that's good. So if that was the only reason, I'm gonna skip it. Yeah. Save me some work. Okay, back to the task at hand. Let's take inventory. We have Alexa, parser, dotted outline of a compiler, and a failing test that tells us that we need to generate 2 bytecode instructions. In our toolbox are the definition of an opcode and its operand. Yeah. The make function that lets us create bytecode instructions are object system that we can use to pass monkey values around, and readable and stunning instructions. I don't have that. And here's a reminder of what our compiler needs to do. Work the AST recursively, find st.integer literals, evaluate them, and turn them into integers. Add those to the constant field, and add op constant instructions to its internal instruction slice. Work the AST, find integers, evaluate them, turn them into, yeah, add those to the constants, and then add up constant instructions to its internal instruction slice. Let's start by walking the AST. That's something we already did in eval. We wrote in the previous book, so there's no reason to change the approach. That's something I didn't do. Here is how we get to our integer literals. Interesting, yeah. I can also do a switch. Nice. C.compile of S. Yeah. Node.expression. Yep, the right side. Well, the only side for expression statement. Infix integer. Okay. I guess when we come across an integer, we need to Well, we need two things. Add an instruction, that'll be up constant, and add the integer itself to the constants. That's easy enough, I guess. Right, this gets us a level deeper in the AST. Yeah, it does. Where we find an expression statement that represents 1 plus 2 in our test. We then compile the expression of that expression statement and end up with ast.infix expression, of which we have to compile the node left and the node right. Yeah. Okay. And I guess when we say compile, adding it to the stack for now. So far, so recursive. But the to-do is right. We need to evaluate them. That's safe to do. Remember, because literals are constant expressions and the value does not change. 2 will always be 2. Right. Isn't it already? Oh, it's an AST literal. Okay. Why do I hear like weird noises? Guess something's happening outside. Okay, when we get an integer, we create an object. Yep. But what? Why does it return an int? Not sure. We append the object to the end of the compiler's constant slice and give it its very own identifier by returning its index in the constant slice. Ah, right. Gotcha. This identifier will now be used as the operand for the up constant instruction that should cause the VM to load this constant from the constants pool onto the stack. Gotcha. Emit, add instruction. Okay, seems like there's a few things to do. It sounds like a problem for tomorrow. Alright, yeah, I think I'm gonna call it today there. Yeah, I have been a bit lazy the last few days, hence the extremely short streams. Okay, but anywho, the name of the game is progress. So gonna end it there. And yeah, as always, have a good one, and I shall see you tomorrow. See ya.